Why do we taste? Our ability to taste has developed out of evolutionary necessity. Early hominids used their sense of taste to identify foods with nutritional value. Taste played a critical role in food selection, allowing our ancestors to find food with high nutrient and energy content. It also helped us figure out what to avoid. If a certain taste makes you sick, you'll be more likely to avoid it in the future. Human taste abilities have evolved since then, but these basic tools of taste still play a crucial role for those who have inconsistent access to food. For humans with easy access to energy-rich foods, our sensitivity to sugary, salty, and fatty foods can lead to nutrition-related diseases like obesity and diabetes. How do we taste? Tasting is the sense that takes in information about the food we eat in 5 forms of different sensations: sweet, sour, bitter, salty, and umami. We sense these tastes with our gustatory caliculi, or what you and I call our taste buds. We have 10,000 taste buds in our mouth. Most of them are on our tongue, but they can also be found on your soft palate, the top of your mouth, and even on the upper part of your throat. If you look at the tongue up close, you can see that it's covered with a lot of small bumps. Those bumps are papillae. Each papilla has many taste buds, and within each taste buds are 50 to 100 receptor cells. Each of these receptor cells have a little hair sticking out of it that helps it sense the chemicals that are released when your saliva partially dissolves your food. When the receptor's hairs come into contact with those chemicals, the receptors can tell whether they are sensing sweet, sour, bitter, salty, or umami. The receptors within the taste buds then send nerve impulses containing that information to your brain, where it processes the taste. Taste and the brain. Nerve endings for the taste system surround the base of the taste bud cells. 3 nerves bring taste messages to the brainstem. The facial nerve, which brings messages from the front 2/3 of the tongue, the hypoglossal nerve, which brings messages from the back of the tongue, and the glossopharyngeal nerve, which brings messages from the throat area and the palate. All of these nerves send their messages to the brainstem, where they combine their signals in the areas of the brainstem that have to do with arousal. Taste messages then join up with smell messages to create the sensation of flavor. We have to know what we are eating, so messages from taste, smell, and chewing meet in the part of the brain called the insula, which identifies what the flavor is. These flavor messages then go to the emotional centers in the temporal lobe and the cingulate gyrus. The messages from all these areas then reach the orbital frontal cortex in the frontal lobe of the brain, right above the eyes. This part of the brain evaluates experience and chooses from among alternatives. Clearly, many parts of the brain are involved in taste. The taste map myth. There is a neural myth that the tongue is mapped in 4 areas: sweet, sour, salty, and bitter. Each taste has a designated area on the tongue. This is why it is called a map. This tongue map was created by a German scientist named D.P. Hannig in 1901. However, in 1942, Edwin Boring, a psychology historian at Harvard, was able to take Hannig's data and calculate real numbers for the levels of sensitivity. When Professor Boring plotted the data on the graph, there was no change in sensitivity, proving that the entire tongue can actually sense these tastes equally. You can even prove this neuromyth false at home. Place some salt at the tip of your tongue where the myth says your sweet taste buds are. It will still taste salty. Next time you have a meal, think about all the work your taste buds and brain put into sensing what you're tasting.